Before starting geometrical constructions chapter, we'll do what's basic proportionality theorem, because I still did not put up my videos on triangles chapter. So just start off with basic proportionality theorem, its proof, because we'll be using this basic proportionality theorem or Thales theorem in geometrical constructions. Basic proportionality theorem or Thales theorem. So what is the statement of this? We'll just say statement is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. This is the statement of basic proportionality theorem. We'll now given over here triangle ABC where DE is parallel to BC. Okay. Now to prove what we have to prove here, we'll see. To prove AD by DB is equal to AE by EC. So from the triangle you can see clearly what we have to prove. Since we are given that D is parallel to BC, we have to prove that AD by DB is equal to AE by EC. Now what is the construction which we are doing here? We'll see. Construction join, you can see in the second figure, join B to join BE, otherwise B to E or BE and CD. You draw DM perpendicular to AC and EN perpendicular to AB. Now what is the proof? We'll see for this. Now area of triangle ADE is equal to, from this figure you can see here, half into base into height. So now this is equal to half into, what is the base over here? ADE is which triangle? This triangle is ADE. So base over here you can take it as AD. AD is the base and the height will become here EN. So if you take this as the first equation, now again you can write this as area of triangle BDE is equal to half into base into height. Now you are getting half into, what will become the base over here? Now you are taking now BDE. So BDE, base we are taking it as DB, and now the height will become EN for this triangle. So DB into EN. Take this as equation 2. Okay, we'll take this as equation 1. Next, now area of triangle ADE. ADE is equal to half into base into height. Now we take whichever triangle, wherever is the perpendicular, it can be external, it can be internal, so we take that only as the perpendicular. So now for triangle BD we got the perpendicular external, that is EN is external of the triangle. So you can get the, depending upon the base, you have to draw a right triangle. Wherever you are getting a right triangle, there that you will consider as the perpendicular. So we got EN as perpendicular over there, it becomes a right angle triangle. So therefore for triangle BDE, the base is BD and EN is the perpendicular, that only we wrote, that is the height. So next over here, half into ADE means it is equal to half into AE into, now we can take DM also is a perpendicular for this, we are taking AE as a base here now. Now next, area of this we take it as equation 3. Now next we have area of triangle DEC is equal to half into base into height, which is equal to half into, here we are taking the base as EC, into height will become DM again here, because it is forming a right angle triangle over here itself. So this part, so for this triangle you can take it in that way. DEC means DEC, EC is the base and here the perpendicular is forming, that is DM. So we are going to take this as the fourth equation. So we got totally now here 4 equations. So now here we are going to divide equation 1 and equation 2. So area of triangle ADE divided by area of triangle BDE, which is equal to half into AD into EN divided by half into DB into EN. So EN half will get cancelled, you are getting AD by DB. Next again divide equation 3 and equation 4. So divide actually by, we are dividing one by the other. So area of triangle ADE divided by area of triangle DEC, which is equal to half into AE into DM divided by half into EC into DM. So DM will cancel, half is, which is equal to AE by EC. Now you take this as equation A and this is equation B. Now triangle BDE and triangle DEC are on the same base D, and between the same parallel lines BC and D. Therefore we have area of triangle BDE is equal to area of triangle DEC. Hence area of triangle ADE by area of triangle BDE is equal to area of triangle ADE by area of triangle DEC, which implies that AD by DB is equal to AE by EC. So from A and B we got this. So therefore it is proved. Hence proved. Chapter 11. This is Geometrical Constructions. The chapter name is directly. We'll start off with exercise 11.1. While doing the problems, we'll see what is it about. Where draw a line segment of length 7.6 centimeters and divide it in the ratio 5:8. Measure the two parts. Find that is the length of those two parts we have to. Now what is the solution? We'll see. So here we will be writing steps of constructions. So before writing the steps of construction, we'll just draw a rough figure. How do we do this? So what do we do is, first we draw basically a line segment AB, which is of length 7.6 centimeters. Then now with A as center, we draw an acute angle below AB and divide this line AX. We name this line as AX. We divide this line AX into 13 parts. Why 13 parts is because it's in the ratio 5:8. So 8 plus 5 is 13. So we're dividing equal ratio 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. We're dividing this into equal parts. That is, now you're having here 1, 2, 3, 4, 5. We name this as 5 and this is A13. So from A13 to B we are joining. First step we have to do is we have to join A13 to B. After joining A13 to B, now a line parallel to this A13B we have to draw from A5 to the line B, such that this A5C is parallel to A13B. Now this is the line segment which divides this in the ratio 5:8. That is, AC is to CB should give you in the ratio 5:8. So this is the way you get this. This in the ratio 5:8 we divide. That is, AB is divided in the ratio. We have to draw A13B parallel to A5. It should be parallel to this. A5C should be parallel to A13B. So now what are the steps of constructions we'll see, and then we'll see how to draw the original figure. So steps of construction, and we'll see even the justification also, because usually they ask sometimes the justification also. So we are going to write even the justification for each and every problem. So draw AB is equal to 5.6 centimeters first. 7.6. We have 7.6 centimeters. Then the second step is, at A draw an acute angle BAX below the line AB. Then the third step is, on AX make 5 plus 8, that is equal to 13, equal parts and mark them as A1, A2, A3, so on A13. Now the fourth step is, we join B to A13. Then from A5 draw A5C parallel to A13B. A5C is the line parallel to A13B. C is the required point of division and AC is to CB is equal to 5 is to 8. So after drawing the figure, we'll measure and see what is the length also we get. So we are drawing the figure now 6 centimeters. So first draw a line segment of 7.6 centimeters. So now name this as A and B. Then from the point A, below A, we're drawing an acute angle like this. Now we are dividing this line is, this BAX is nothing but an acute angle less than 90 degrees. Now we are going to divide this into 13 parts, 5 plus 8. So with 1 centimeter you can take with your compass and then draw arcs in such a way that 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13. So you got 13 arcs. Now from this part, now you can take, so from this point A13, this is A13. So I am going to name all these. These are A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11, A12, A13. A13 we are going to join to B. B to A13 I am joining. Now a line parallel to A13B we are going to draw in such a way that now we have to take the scale just in this way. We have to just move it in such a way that where it reaches the point A5, and from A5 we draw a line onto AB. So now this is of length 7.6 centimeters we have drawn first. This one. Now this point is called as C. Now A5C, C is the required point. A5C is parallel to A13B, and now we measure what is AC and CB. AC is equal to 3.1 centimeters and CB is equal to 4.5 centimeters. So now from here we'll write what is the justification part. This is the way we construct this way. So on measuring we get, we get AC is equal to 3.1 centimeters and BC or CB is equal to 4.5 centimeters. So total will come to 7.6 centimeters. Now what is the justification we'll see over here. We use basic proportionality theorem. So here since A5C is parallel to A13B, therefore A5 by A5 A13 is equal to AC by CB. This is using basic proportionality theorem. But we know that A5 by A5 A13 is equal to 5 by 8. Therefore AC by CB is equal to 5 by 8. This shows that C divides AB in the ratio 5 is to 8. So now going into the second problem. What is the second problem? Let's see. Construct a triangle of sides 4 centimeters, 5 centimeters, and 6 centimeters, and then a triangle similar to it whose sides are 2 by 3 of the corresponding sides of the first triangle. So now here we are having one ratio being given. We have to construct a triangle and one more triangle similar to that, which is 2 by 3 of the corresponding sides of the given triangle. So now how do we do this? Solution, we'll just go into the solution over here. Before going into the steps of constructions, we'll just see what is the rough figure for this. So we are given a triangle whose sides are 4, 5 and 6 centimeters respectively. So now what do we do is we always take the bigger side, that is 6 centimeters on the base. This is the rough figure I am drawing. Then we mark this as AB. With A as center, draw an arc of 4 centimeters in this way. Then with B as center, draw an arc meeting the previous arc at intersecting the previous arc at 5 centimeters. Now join this and mark this point as C. So now you have got this triangle. This is the given triangle for us. This is 4 centimeters and this is 5 centimeters. Now after drawing this, now what do we do is from A, below AB, we make again one and name it as X over here, somewhere here. Now what do we do is, now because we have to draw a triangle 2 by 3 of the corresponding sides of the first triangle, we are going to divide this AX into 3 equal parts. So I am taking it as, you can 1, 2, 3. Now you can name this as A1, A2, A3. These arcs should be drawn in such a way that A1 is equal to A1, A2 is equal to A2, A3. Now from A3 to B you join. After joining from A3 to B, now what do we do is, now we take a line parallel to from A2, which is parallel to A3B. Using the scale or using the set square you can do, so both the set square, and you name this point as B dash. Now from B dash we draw a line parallel to BC onto AC. So and we name this line, it should be exactly parallel to BC. So we have to take the scale from BC, bring it this way so that it is parallel and it becomes here C dash. This point becomes C dash. Now A, B dash, C dash is the required triangle. We have to get that these two angles also should be equal. They should be parallel, means these two angles will be equal. So using the set square you can do that. Now steps of constructions, before going into the original diagram, steps of constructions, how do we do? Now there's even one more way you can take the compass also and draw the lines. I'll just tell you how to do that while doing this. So the first step is, now construct triangle. Construct a triangle ABC in which AB is equal to 6 centimeters, AC is equal to 4 centimeters and BC is equal to 5 centimeters. So second, at A, draw an acute angle BAX below AB. Then third one is, along AX, mark off points A1, A2 A3 such that A1 is equal to A1 A2 is equal to A2 A3. Then fourth point is join A3B. Then fifth one is from A2 draw A2B dash parallel to A3B meeting AB at B dash. Then the sixth point is from B dash draw B dash C dash parallel to CB meeting AC at C dash. Thus triangle AB dash C dash is the required triangle, each of whose sides is 2/3 of the corresponding sides of the triangle ABC. A and B. With A as center, draw an arc with the compass which is 4 centimeters. Then again with B as center, draw another arc meeting this arc with 5 centimeters. Then join, name this point as C. Then join from A to C, and then from B to C, and name this as, this is 5 centimeters, this is 4 centimeters, this is 6 centimeters. Then make an acute angle from A and name this part as X. Then divide this into 3 parts because you are having 2 by 3. This 2 by 3 is nothing but it is called as the scale factor, because 2 by 3 is less than 1. You will get the triangle inside the original triangle. If 2 by 3 is greater than 1, you will get the triangle outside the original triangle. This is called as the scale factor. This is called as the scale factor. Sometimes I'll give you scale factor is equal to 2 by 3. That means it is less than 1. You will get a triangle inside the original triangle. Now what do? Is we divide this triangle into 3 equal parts because it's in the 2 by 3 times corresponding sides of the first triangle. So this is first 1, 2, 3. So now this, all these A1 should be equal to A1 A2 should be equal to A2 A3. So now from this we are joining it to B, we are joining to A3. Now this is the first step which you are having. Now what do? Is here you take the compass, you put it on A3. Okay, now here after putting it on A3, you draw an arc in such a way that you get it in this way. Now the same arc you go to A2, again do the same arc in the same way, put this with the same radius, you just draw the arc in the same way. Then come back to this point here, this point which I have put it in this, I marked it here red. From here to this arc, this point, you just measure this measurement and then come back to this point here which is on this, and then I'll just, from this green point you put the compass here and measure the distance from here to here. After drawing the arc, taking A3 as center, you drew an arc in this way, no? Now with then the same arc with the same radius you are drawing from A2. Then what do? Is measure this distance from this green one to this green point to this two green points. So this green point from here to the same measurement you have to put over here. After putting it, now you can just join it from A to, just passing it through this green line. You can draw a line in this way. So now these two lines will become parallel, that is A3 and A2. We'll name this as B dash. Okay. So now in the same similar manner we do it even for this also. We take B as the center here and you just draw an arc in this way. Now you measure the distance from here to here. Here again you go to B dash. You draw the same way. This from B to whatever arc you have drawn. You just draw one more arc in that way. Then measure the distance from here to here. The same way from here to here. Just mark a point on this. And then you draw a marking this. So therefore this, now name this as A, B dash, C dash is the required triangle. I'll just draw it in a different color if not original one. A, B dash, C dash is the required triangle. Now we'll just see what is the justification part for this. You have here A3B is parallel to A2B dash. This is by construction we have got this. So therefore A2 by A2 A3 is equal to AB dash by B dash B, but A2 by A2 A3 is equal to 2 by 1. Therefore A B dash by B dash B is equal to 2 by 1. Therefore B dash B by A B dash is equal to 1 by 2, which implies that B dash B by A B dash plus 1 on both sides. So we are going to get this as B dash B plus A B dash by A B dash is equal to 3 by 2. So which implies that AB by AB dash is equal to 3 by 2, or which implies that AB dash by AB is equal to 2 by 3. So now taking this as the first one, therefore we have, since BC is parallel to B dash C dash by construction, therefore we have now triangle AB dash C dash is similar to triangle ABC using AA similar condition. So therefore C dash A by C AC is equal to C dash B dash by BC is equal to A B dash by AB, which is equal to 2 by 3. Hence proved. So this is by which by basic proportionality theorem we have this. So by basic proportionality theorem we came to this conclusion. So now going into the Third problem. What's the third problem? We'll see. Construct a triangle with sides 5 centimeters, 6 centimeters and 7 centimeters. Then another triangle whose sides are 7/5 of the corresponding sides of the first triangle. So this also we can, in the same way we can draw rough figure, but without the rough figure, and we'll be doing for this. So what are the steps of constructions? We'll see. First, again we have to construct a triangle. So first, construct a triangle ABC in which AB is equal to 7 centimeters. Always we take the base as the biggest side. So that is, we are taking it as 7 centimeters. Then AC is equal to 5 centimeters and BC is equal to 6 centimeters. Then the second point is we construct triangle. The first step was only we construct a triangle. Now at A we draw an acute angle. Draw an acute angle BAX below AB. Third one, along AX mark off 7 points. Now here you are having numerator is greater than the denominator, the scale factor is greater than 1. So you will get a triangle which is outside the original triangle. So 7 points. Now whichever we have in the ratio, the bigger number, we mark so many points. So here we are having 7 points we mark on this. 7 points, that is A1, A2, A3 and so on up to A7, such that all of them are at equal distance. A1 is equal to A1, A2 is equal to A2, A3 and so on is equal to A6, A7. So now fourth step, we join A5 to B. Now here what is the least number? We always join it to the external, that is B. A5 to D we are joining here. B part, that is after drawing the line. Then the fifth point is from A7 draw A7B dash parallel to A5B. Meeting AB at B dash. Extend the line, that is produced part. Next, the sixth point is from B dash draw B dash C dash parallel to BC intersecting the extended line segment AC at C dash. Thus, A B dash C dash is the required triangle, each of whose sides is 7/5 of the corresponding sides of the triangle ABC. So the justification part after drawing the figure we'll just see. So we name this as, this is 7 centimeters. Now from A as center we draw an arc which is 5 centimeters. Then from B one more arc which is 6 centimeters. Then join them. A to C we are joining. Then B to C. B to C is this one. BC is 6 centimeters. This is 5 centimeters. Now we are going to draw an acute angle from A. We are making an angle ABAX, which is an acute angle. So BAX this is. Now we are going to divide this into 7 parts because you are having it should be another triangle whose sides are 7/5 of the corresponding sides of the original triangle or the first triangle. So equal they have to be 1, 2, 3, 4, 5, 6, 7. So we got here this as A1, A2, A3, A4, A5, A6, A7. Now from whatever is in the denominator, that is 7/5, isn't it? Now 5, this A5 should be joined to B. A5 should be joined to B. To B dash. This you extend this line over here. This is the extended part which we are having. This is B dash. Now in the similar manner, here it will be extended, even here also top it will be extended. I forgot and adjusted this triangle in this way. It will come on to this writing over here, so no problem. But so now you can BC. So you can take the set square or your scale also in such a way that from B to C. Oh, just look at it, the full one here. You're having it in this way. So now what is the justification part we'll see here from this now. Justification. Again using the basic proportionality theorem itself, we'll be doing the justification here also. So you're having, since B dash C dash is parallel to BC by construction, you can see from this B dash C dash is parallel to BC. So and also you're having that, and triangle A B dash C dash is similar to triangle ABC using AA similar condition. Therefore, C dash A by CA is equal to C dash B dash by CB is equal to AB dash by AB. Since A7B dash is parallel to A5B by construction, which implies that triangle A7B dash is similar to triangle A5B using AA similar condition, which implies that AB by AB dash is equal to AA5 by AA7, but AA5 by AA7 is equal to 5 by 7 by construction. Therefore, AB by AB dash is equal to 5 by 7. Therefore, AB dash by AB is equal to 7 by 5. Therefore, C dash A by CA is equal to C dash B dash by CB is equal to AB dash by AB, which is equal to 7 by 5. This is the required justification which you are having. Now going into the next problem, that is question 4. Construct an isosceles triangle. Construct an isosceles triangle whose base is 8 centimeters and altitude 4 centimeters, and then another triangle whose sides are 1.5 times the corresponding sides of the isosceles triangle. So here also I am not drawing a rough figure, directly we will go into the steps of construction and then we will draw the figure. So what are the steps of construction here? First we have to draw an isosceles triangle, because it's given to construct an isosceles triangle whose base is 8 centimeters and altitude is 4 centimeters. Altitude means we have to draw a line perpendicular to this. The first step is draw a line segment BC equal to 8 centimeters. Then second step is draw a perpendicular bisector AD 4 centimeter from BC. Now third step is joining AB and AC. We get an isosceles triangle AB. Isosceles triangle ABC. Then the fourth step is construct. Again we have to always take an acute angle below the given line, whatever is the given line. So construct an acute angle CBX downwards below, we can write below BC. Now here we have to again write whose sides are 1.5 times the corresponding sides of the isosceles triangle. Means 1.5 means it's 3/2. Here again you will get a triangle which is exterior, which is bigger than the original triangle because it's the scale factor is greater than 1. So now the fifth point which we are having here is along BX mark of 3 equal points B1, B2 and B3 such that B1 is equal to B1, B2 is equal to B2, B3. Then sixth one is join C2, B2 and draw a line through B3 parallel to B2C intersecting the extended line segment BC at C dash. Because it's being extended, after getting extended only we'll see from the construction part. I'm first writing it down and then I'm going to do it. Now the seventh point is again draw parallel line C dash A dash to AC cutting BP at A dash. So here now the eighth point here we are having is triangle A dash B C dash. A B C dash is the required triangle. So now how do we draw this figure? We'll just see. First we have to with the same radius with CS center draw another arc meeting each other, they are intersecting at a point. So then draw an perpendicular bisector to BC. This is the altitude for BC. Then join from B to C and B to A to B. This is A. So now we have the base BC as 8 centimeters. We draw a perpendicular bisector. Now AB is also equal to 4. This is 4 centimeters altitude. So now these two will be of equal length. Therefore it forms an isosceles triangle. So after drawing the perpendicular bisector, we measure 4 centimeters. Then draw the arcs. Acute angle at B. This is the acute angle, marking this as x. Now again we take equal arcs from this point, 3 arcs. So 1, 2, 3. So this is B1, B2, B3, such that B1 is equal to B1, B2 is equal to B2, B3. Now join B2 to C. Now we draw a line which is parallel to B to C. So we get one more line, B3C dash, which is parallel to B to C. Now this is C dash. Now we extend even this line over here. AB is also extended. Then we draw a line parallel to AC, such that we get it as C dash A dash. Now A dash C dash B is the required triangle. So now we justification. Since C dash A dash is parallel to CA by construction, therefore triangle ABC is similar to triangle A dash B dash C dash using AA similarity condition. Therefore we have A dash B by AB is equal to A dash C dash by AC, which is equal to BC dash by BC. Since corresponding sides of two similar triangles are proportional, since B3 C dash is parallel to B2 C by construction, therefore triangle B3 C dash is similar to triangle B2 C by AA similarity criterion. Therefore BC dash by BC is equal to BB3 by BB2 by basic proportionality theorem. But we know that BB3 by BB2 is equal to 3 by 2 by construction. Therefore BC dash by BC is equal to 3 by 2. Therefore we have A dash B by AB is equal to A dash C dash by AC is equal to BC dash by BC, which is equal to 3 by 2. Now fifth one. First now we'll draw the triangle before writing the constructions. So draw a triangle ABC with side BC is equal to 6 centimeters, AB is equal to 5 centimeters, and angle ABC is equal to 60 degrees. Then construct a triangle whose sides are 3/4 of the corresponding sides of the triangle ABC. So now before writing steps of construction, we'll first we'll draw the figure for this. So first we'll draw a base of 6 centimeters and AB is equal to 5 centimeters. And angle ABC is equal to, we have to make an angle of 60 degrees at that point. So let the base color be here. Base be 6 centimeters. BC is equal to 6 centimeters. Now we'll make an angle of 60 degrees over here. Angle of 60 degrees over here, and mark on this 5 centimeters. This is AB. This is 5 centimeters. Then join A to C. Now again we draw an acute angle. CBX is equal to less than 90 degrees an angle. So we take a ray BX. Now this has to be divided in the ratio 3/4. Since this is less than 1, it is going to be a triangle inside that. So we are going to divide this into what is great, which part is greater, 3 or 4. 4 it's greater, so 1, 2, 3, 4 parts we are dividing this. This is B1, B2, B3, B4. Now from the bigger part we have to join to C. So we are going to join B to C, B4 to C. A line, it should be divided in ratio 3/4. Line parallel to B4C, that is B3. This is C dash. Then again from this point C dash, we draw a line parallel to CA. Using the set square you can draw. This we name it as A dash. So required triangle is B C dash A dash or A dash B C dash. We get it in this way. So now what are the steps of constructions, we'll just see. First only we drew the triangle here, and this triangle, because the scale factor 3/4 is less than 1, we are getting it inside the triangle. For this one it was outside, because you're having it as the ratio is how much here, 3/2. So 3/2 is greater than 1, so therefore it is outside. So now steps of constructions for this solution. So solution or steps of construction. First step, Draw triangle ABC with side BC is equal to 6 centimeters, AB is equal to 5 centimeters, and angle ABC is equal to 60 degrees. Second, draw any ray BX making an acute angle with BC on the side opposite to the vertex A. Third one, along BX mark off points B1, B2, B3 and B4 on BX such that B1 is equal to B1 B2 is equal to B3 B4 B2 B3 this is equal to B3 B4. Fourth point is join B4C and draw a line through B3 parallel to B4C intersecting BC to C dash. Fifth one, draw a line through C dash parallel to the line CA to intersect BA at A dash. Then A dash B C dash is the required triangle. Now justification for this. Since B4C is parallel to B3C dash by construction, therefore B3 by B4 is equal to BC dash by BC by basic proportionality theorem. But B2 by B4 is equal to 3 by 4 by construction. Therefore BC dash by BC is equal to 3 by 4. The first one. Since BC dash by BC is equal to 3 by 4, then CA is parallel to C dash A dash by construction. Therefore triangle BC dash A dash is similar to triangle BCA using AA similarity condition. Therefore we have A dash by AB is equal to A dash C by AC is equal to BC dash by BC which is equal to A dash C by AC is equal to BC dash by BC, which is equal to 3 by 4. And this is from 1 by basic proportionality theorem. Now the sixth question. Draw a triangle ABC with side BC is equal to 7 centimeters, angle B is equal to 45 degrees, angle A is equal to 105 degrees. Then construct a triangle whose sides are 4 by 3 times the corresponding sides of triangle ABC. Now here we are having the scale factor 4 by 3, it is greater than 1, so you will get the triangle greater than the original one. So we have to check whether it is greater than 1 or less than 1. Now we have to draw this triangle. We are given that angle B is equal to 45 degrees and angle A is equal to 105 degrees. So first solution. First you can draw a base of BC of 7 centimeters. Of 7 centimeters. So from B we make an angle of 45 degrees using the protractor. Using the protractor you can make an angle of 45 degrees. Now again using a protractor you can make an angle of 105 degrees from C. So this is 105 degrees, this you are naming it as A. Now here again from B we draw an acute angle such that we draw an ray BX such that CBX is acute less than 90. So then on this we mark how many are there, totally 4 by 3. So 4 we have to mark, 1, 2, 3, 4. So B1, B2, B3, B4. So from this largest number of both, 4 is the largest, from there we have to join to C. No. So from B4 to C we have to join. I'm sorry, whatever is the denominator we have to join. That is B3 to C we are joining. Because 3 is in the denominator, we join from B3 because this is going to be an external one. So we are joining from B3 to C. Now we have to draw a line. So we are going to use the set square, or you can use your compass and scale, or you can use only set squares, both the set squares, to draw parallel lines. So this is the way you have to draw. You have to join it. So from B3C we join it from here to here. We extend this line BC to C dash. C dash. Then from here again you draw a line parallel to AC, that is A dash C dash it becomes. This line also will extend. So our required triangle is A dash B C dash. This is the required triangle. Usually if the figure is drawn correctly, you no need to write the steps of construction, but sometimes they ask even for justification also. If you write the steps of constructions, if you're having time, you can write down in your exam. Steps of construction. How you drew the figure, using what you drew the figure also you can write down. The first one, draw a triangle ABC with side BC is equal to 7 centimeters. Angle B equal to 45 degrees. You can use a protractor over here. Angle A is equal to 105 degrees. Then second one is, if you know how to draw with the compass, you can draw. It's easier both the ways. So draw any ray BX making an acute angle with BC on the side opposite to the vertex A. Third one, along BX mark off 4 points B1, B2, B3 and B4 on BX such that BB1 is equal to B1, B2 is equal to B2, B3 is equal to B3, B4. Then join B3 to C and draw a line through B4 parallel to B3C intersecting the extended line segment BA at A dash. Then A dash B C dash is the required triangle. Justification. What's the justification for this also we'll see. Now since you can see from the figure, always see into the figure and then write down this. C dash A dash is parallel to CA by construction. Therefore, triangle ABC is similar to triangle A dash B dash C dash using AA similarity condition. Therefore, A dash B by AB is equal to A dash C dash by AC, which is equal to BC dash by BC. Since corresponding sides of two similar triangles are proportional, we have B4C dash is parallel to B3C by construction. Therefore, triangle BB4C dash is similar to triangle B3C using AA similarity condition. Therefore, BC dash by BC is equal to BB4 by BB3 by basic proportionality theorem. But we also have that BB4 by BB3 is equal to 4 by 3 by construction. Therefore, BC dash by BC is equal to 4 by 3. Therefore, A dash B by AB is equal to A dash C dash by AC, which is equal to BC dash by BC, which is equal to 4 by 3. Now next, going to the last problem of this exercise, the 7th one. Draw a right triangle in which the sides other than the hypotenuse are of lengths 4 centimeters and 3 centimeters. Then construct another triangle whose sides are 5 by 3 times the corresponding sides of the given triangle. That is, the scale factor here is greater than 1, so therefore you will get a triangle which is outside the original one. So now how do we draw this? First we have to draw a right angle triangle. If you know how to use the Pythagoras theorem, you can just do it by writing. You know that two sides are 3 and 4. So because these two are the legs of the triangle, or the base, or the base and height. So 3 square plus 4 square, that's 16 plus 9 is equal to 25. So you're getting 5 as the other side. You can draw a right angle triangle with all these 3 sides. First, so base is 4 centimeters. Then draw a right angle here. Use the protractor, or you can use even your compass. So this is a right angle. This is 90 degrees over here. You can take this as BC. This is 4 centimeters. So now this is over here, you're having it as 3 centimeters, means you can just join it at 3 centimeters from here to here. This is 3 centimeters. So you can name this as A. Now from B, we draw an acute angle. Now this is 5 by 3 times the original triangle. So therefore here you draw BX. CBX makes an acute angle, or BX on BX ray. We make how many points? 5 points. Which is the biggest number, 3 or 5? So 5 is the biggest number. What is in the denominator? We join it to C here, the original one. So therefore here this is B1, B2, B3, B4, B5. So B2, B3, B4, B5. What is in the denominator? 3. So B3 to C we join. B3 to C we join. Next what do we do? From B5 now we draw a line parallel to, we extend first BC. We extended the line BC. Now we draw a line parallel to BC from B5. So B5 C dash is parallel to B3C. Now from C dash we draw one more line which is parallel to AC. So putting the set square in that way, you draw a parallel line, or you can use your compass or even the scale. With the scale also you can do this. You name it as A dash. So now the required triangle is A dash BC. This is the required triangle. So now how do we write the steps of construction for this CBSE? So I given basic proportionality theorem. I'll just explain what is basic proportionality theorem. Solution. Here only you started off construction. Steps of construction. First, what did we do in this? We drew the base BC first. Draw a line BC equal to 4 centimeters. Second, you draw BA which is equal to 3 centimeters line segment with 90 degrees at B. Then third, what did we do? Join AC to form a right triangle ABC. Then the fourth one, construct an acute angle CBX downwards. BC, you make an acute angle down of BC or below BC. Then fifth one, is along BX mark of 5 equal points B1, B2, B3, B4 and B5 such that B1 is equal to B1, B2 is equal to so on B4, B5. Then sixth one, join C to B3 and draw a line through B3 parallel to B3C, intersecting the extended line segment BC at C dash. Seventh one, again we draw C dash A dash parallel to AC. Thus triangle A dash B C dash is the required triangle. Justification. Since C dash A dash is parallel to CA by construction, therefore triangle ABC is similar to triangle A dash B C dash using double similar condition, which implies that A dash B by AB is equal to A dash C dash by AC, which is equal to BC dash by BC, since corresponding sides of two similar triangles are proportional, since B5C dash is parallel to B3C by construction, therefore triangle B5C dash is similar to triangle B3C using double similar condition. Therefore BC dash by BC is equal to BB5 by BB3 by the basic proportionality theorem. But BC5 by BC3 is equal to 5 by 3 by construction. Therefore BC dash by BC is equal to 5 by 3. Therefore A dash B by AB is equal to A dash C dash by AC, which is equal to BC dash by BC, which is equal to 5 by 3.